a native bush area increases at a rate proportional to the number present after time of T months. Initially there are that many possums, after 1 year there are that many. At this rate of increase, how many possums will it be after 2 years? Yeah, it's recording here, you happy with that? Alright, what's our differential equation? dn over dt? Yep. Equals kn. So the rate at which the number of possums is increasing proportional to time is equal to, is proportional to the number present. Happy with that? Alright, that's just the differential equation. Separate the variables and integrate through. What am I going to do there? Divide both sides by n. Leave the k on that side, just like you've been doing. So we're going to separate the variables. We're going to move the k over, the n over here. We're going to move the dt over there. We're going to make it 1 over n dn equals k dt. That's what we're going to do. As I said before, it's not entirely accurate that we're doing it. Our algebraic manipulation isn't accurate, but it's a way of thinking about it. You happy with that? Okay, what does the k represent? A number that is the proportional part of our increase. Happy with that? Now when I integrate this side and I integrate this side, I'm going to get the natural log of n is going to be equal to kt plus c. Happy with that, eh? Okay, now I can manipulate this, and again, might not algebraically be correct, but if I raise everything to the power of e, what happens to the log, natural log, and the e? Cancels out. So what we've got over here is we've got n is going to be equal to e to the kt plus c. Happy with that? What is k and what are c? There are two constants that we're going to try and solve for. But I've written that out in the past, eh? How have I written that out? Yeah, I've written it out with an A. Do you remember how you got to the A? Yeah, it's going to be e to the kt times e to the c. Because remember, if you're multiplying something with the same base, you can add those indices, just like x squared times x cubed. That's the same as x to the power of 5. You can add those indices. And this here is just a number, isn't it? That's just a number. Because we're multiplying by that, we can just go straight to n equals a e to the kt. You happy with that? Yeah. What have I called a in the past for you guys? Is that? Yeah. Why is it the initial value? Yeah. Well, not necessarily that, but so at t equals 0. So at time 0. At time 0, from our question, we scroll back up. Initially, there are 1,000 possums. So at time 0, what does n equal? Well, n equals a, yeah. Why does n equal a? Because e to the 0 is 1, isn't it? So n equals a, so 1,000 is obviously going to be a. So that's going to be an equation we're going to start working up our equation. 1,000 e to the kt. Happy with that's where our equation's heading now. Now, what are we going to try and do? Work out k. Exactly. How are we going to work out k? Yeah, substitute the other point in. All right, so we've got after 1 year, 1,250 possums. Okay, so at time equals 1, n equals 1,250. Happy with that? So what am I going to do here? Substitute in. Alright, so 1,250 equals 1,000 e to the k, isn't it? Now that's just an equation I have to solve. That is a log equation I have to solve. So what do I do first? Divide both sides by 1,000. What's 1,250 divided by 1,000? I'm glad some people didn't just reach for their calculators. So 1.25 equals e to the k. How do I solve that now? Yeah, natural log both sides, yep. Again, if you've forgotten that, look at your log stuff. Okay, that there is an expression, x equals by on my log formula sheet. Y equals log to the base b of x. Our base is e, so we just use the natural log. But again, what we can sort of do is set the natural log of both sides, and again, it sort of cancels. Not algebraically purely correct, but that's what happens. Happy with that? So now all I've got to do is go, what is the natural log of 1.25? So I go over to my calculator, which has been sitting here. 1.25 gives me an answer of 0.223. 1.4. Think of the answer? Yep. So therefore my equation starts slowly taking shape. It's going to be equal to 1,000 e to 0.223 t. I can go further if I want to, I'll just leave it as 0.223. Happy with that? So is that my answer? Let's go back up to the question. At this rate of increase, how many will be there after 2 years? Yeah, okay. So we haven't answered my question yet. Okay, so make sure you answer the question. So how do I answer this question? Substitute t of 2. Yeah. So at t equals 2, n is what? Okay. So n equals 1,000 e to the 0.223 lots of 2. Happy with that? Now if I've got my answer in my calculator here, what I can do is just go 1,000 times e to the power of 2 times my answer. So I haven't used 0.223 as I haven't used exactly that answer. I've used the rounded answer from my used up back there. You ever make sense of that? Okay, so I've said k is 2, 2, 3, 4, 1, 4, 3, 5, 5, 1, 3 from up there on my calculator. So I press equals 156.12. What 25? What did I do wrong there? Yeah, okay. You ever happy with that? I'm not going to go through and change it again, but I should have had 1,000 there instead of 100. So it should have been 1,000 there. Okay. If I do that now, I'm going to change my answer. Who can remember that number that was just there? 156.25. So we're going that? Yeah. Are we going that? Man, we should have just really did it again, eh? Let's just do it again. You guys are hopeless. Log 1.25, good. Yes. That's my answer now. That's in my, yeah, so we'll go across, make it 1,000, 150 Yeah, 1,562.5. That's our answer? Yeah. Happy? How many possums are present? Ooh. 1,562.5? Yeah. Which one would you do? Who'd go 1,563? The reason why? 0.5 rounds up. Who would go 1,562? Why? Yeah, half a possum. It's nearly there, not year there. Nearly there, but not year there. Have you got 1,563 possums? You know, your model predicts 1,562 and a bit. So I can understand both answers, but my answer, I would assume, would be that. And I believe you'd probably get both marked correct. Happy with that? Does that look like a long process? But here's my excellent stuff. Okay, so if I zoom out, a little bit of working there. Use your standard differential equation stuff, and then just go through and okay, rightio. Now I'll just change the colour if I can, please. Oh, this is embarrassing now. Can I go away? Yeah, thank you. Yeah, it's still in the video, unfortunately. And then we're going to substitute in and solve for one of our unknowns. Don't change. And then we're going to substitute in a second point, and then get our final function, and then we're going to answer the actual question. So make sure that there are 4 parts of that question. But is there that much that's tricky about it? Like, it's an excellence question, but all those steps aren't that challenging in isolation, are they? But when you put them all together, that's where we start getting lost. There's more and more room for errors. But anyway,
Like and subscribe.
oh.